Hi, hello, how are you? This is your Gopal. Welcome to Physics Rank Guru. Today we are going to discuss gravitation lecture number 3. So in gravitation lecture number 2, we can discuss relation between acceleration due to gravity and gravitational constant and the variation of acceleration due to gravity in terms of altitude means height, in terms of depth, in terms of latitude, in terms of shape you can discuss. Okay, so in lecture number 3 you can discuss gravitational field strength or gravitational intensity or acceleration due to gravity. Gravitational field strength or intensity that becomes G, acceleration due to gravity. So what is gravitational field strength? So I will consider a small body of mass. You can release that mass, so that body moves, the body becomes motion. So why the body becomes motion means, so you can consider the screen. Behind one source is there, that is gravitation. That mass of this behind the source mass is m and radius is r. Due to this source, an imaginary field is invisible. And but you can feel its effects. Due to this source, this body moves in this direction. So what is gravitational field means? Gravitational field strength or gravitational field is equal to the force experienced by a unit mass. That mass placed in a point in the gravitational field. Gravitational field. The force experienced by unit mass is called what? Gravitational field. Is called gravitational field strength. The force experienced by unit mass. It is kept in a point in the gravitational field. That it kept in a point in the gravitational field is called what? Gravitational field strength. So we know what is the gravitational force here. F, gravitational force, that is a act on the body is mass m, small m. That is a test mass. Your condition is limit that mass tends to be 0. Your condition is what? That is a test mass. This is test mass. Limit that m tends to be 0. So what is the gravitational force here? Capital G, capital M, small m by r square into m. This m cancel. So E is equal to, suppose here to here distance is r. We can consider this is r square. So E is equal to capital G, capital M by r square. Capital G, capital M by r square is equal to what? Acceleration due to gravity. What is SI unit of gravitational field means? Force means you can measure in newtons. Mass means you can measure in kilograms. Newton per kg, or you can write Newton kg minus 1. Newton kg power of minus 1, or you can write acceleration due to gravity meter second minus 2. It is a vector physical quantity. You can place a unit mass in a gravitational field. Due to this gravitational field, so the body experiences the force. force. This is the mass of the body. So what is here? Gravitational field is equal to force by unit mass. Force by unit mass. What is the direction of here gravitational field? Direction of gravitational field strength is along the direction of force. Direction of gravitational field strength is along the direction of force. Along the direction of force. Next, gravitational field due to point mass. Suppose consider a mass of the body of mass is m, and suppose you can consider a mass, test mass. So due to this gravitational field, so in this one force is acting. Due to that force, so gravitational field acting in this direction. So from here to here distance is what? R. The field due to point mass, you can write, so E is equal to F by M, or you can write capital G, capital M, small m by R square into M. This m cancel. So E is equal to capital G, capital M by R square. So this is field due to gravitational field due to point mass. And this gravitational field towards the capital M. Field due to point mass towards mass capital M. Towards mass capital M. Two masses. This is mass m1 and this is another mass m1, m2. So I will consider this is mass is m1 and this is mass is m2. Field due to this point P you can find out. Field due to this point. So due to this mass, gravitational field act in this direction. That is I will consider E1. Due to this mass, gravitational field act in this direction. That is I will consider E2. What is E1? So here to here distance is R1 and here to here distance is R2. What is the gravitational field E1 here? E1 is equal to capital G M1 by R1 square. What about E2? Capital G M2 by R2 square. So what is the net gravitational field here? Net gravitational field is equal to E1 plus E2. The net gravitational field E1, E2 means the vector sum of two gravitational fields. Vector sum of two gravitational field. So this is a principle of superposition. Principle of superposition. Principle of superposition. So principle of superposition means the vector sum of the two gravitational fields. Net gravitational field is equal to vector sum of two gravitational fields. So based on this you can do an example. You can do the one problem, small problem. So we can see one example. So based on superposition. So consider three identical masses are placed vertices of a triangle, vertices of a equatorial triangle. Vertices of a equatorial triangle. Of a side is A. Of a side is A. So you can find the gravitational field at center O and at point P. So here you can find out gravitational field at point O and at a point P you can find out. At point P. So first I will find gravitational force at a point O I will find. Gravitational field at a point O I will find. So due to this mass, so all are identical masses, means all are m. Due to this mass, gravitational field act in this direction. Due to this mass, gravitational field act in this direction. Due to this mass, gravitational field act in this direction. So these all equatorial triangle means all angles 60 only. So due to this 60, what about this angle? Suppose I will drawing here this point O. This is a point O. One field is acting upward, and one field is acting in this direction, and one field is acting in this direction. So this is symmetry, exactly symmetry. This is 30 degrees, and this is also 30 degrees. This is 30, this is 30, means this is 120 degrees. So this is how much, Amma? 120 degrees. Okay. So you can draw one symmetry line here, reference line. So this is net field. Net field act in this direction. Net field. So this is 120, means what about this one? 60 degrees. Means along the 60, what about E? So we can write this E resolve into gravitational field resolve into two components, along the horizontal, along the vertical. Along the vertical, what about this component E cos 60? E cos 60. Along the horizontal, E sin 60. E sin 60. Due to this also same. This is E sin 60. And one more here, E cos 60. So what about net field here? Net field E net is equal to 2 times of E cos 60. 2 times of E cos 60. So what about E sin 60 and E sin 60? This both are cancelled each other. So net gravitational field act in this direction. So that is 2E cos 60. So 2 into E cos 60 value is 1 by 2. These two cancel. So net gravitational field in this direction is E. Okay, now see the gravitational field upward is E and downward also E. These two are cancelled. So net gravitational field here 0. At the center O is 0. So net gravitational field at center O is 0. Understood, all of you? So next you can find out gravitational field. So here net gravitational field along point O is 0. At O, net gravitational field is equal to 0. You can find out gravitational field at a point P. At a point P you can find out. Right? So I will draw here. Here you can find out net gravitational field. These are identical masses M. This is M, this is M, this is M. So due to at point P, here gravitation, due to this mass, gravitational field act in this direction, that is E, and due to this mass, gravitational field act in this direction. So these two are same magnitude and opposite direction. So these two are cancelled. Okay, now you can find out gravitational field due to this mass. So this gravitational field you can find out E. Means you can find out this distance first. You can find out this distance. So this is all sides given what A, equal triangle of a side is A. So this is A by 2. This is A by 2. This is a right angle triangle. By using Pythagoras theorem you can find out this distance. So here this E is equal to, suppose this is, I will consider that Y. I will consider this distance is Y. You can find out this Y distance. So Y, this hypotenuse side, the hypotenuse A square is equal to A by 2 whole square plus Y square. I want Y square. Y square is equal to A square minus A square by 4. You can write this one 3A square by 4. This is Y square. No, Y is equal to root 3A by 2. Root 3A by 2. So here you can find out what is the gravitational field. E is equal to capital G M by Y square. What about here Y? So capital G M by root 3a square. A square means root 3a by 2 means what? 3a square by 4 means 4gm by 3a square. 4gm by 3a square. E is equal to 4 capital G m by 3a square. So this is the gravitational field at P. Gravitational field at P 4 gm by 3a square. Yes, mass is distributed symmetrically. Mass is distributed symmetrically. Mass is distributed symmetrically. The mass is distributed symmetrically. The gravitational field is 0. Gravitational field is 0. Suppose, now we will discuss. So equilateral triangle, the uniform mass is identical mass placed at the vertices of a side is A. So what is the field due to at center? So here gravitational field act in this direction, here act like that, here act like this. Your field at center E is equal to 0. So similarly you can take the square of a side is A. The uniform particles or the identical masses are placed at corners. So this is M and M. So field due to at center. Due to this mass, gravitational field act in this direction. Due to this mass, gravitational field act in this direction. Due to this, act like that. Due to this, act like that. Here also gravitational field, net gravitational field E net is equal to 0. Similarly, you can consider a circle. At the center, gravitational field is equal to 0. At center, gravitational field is equal to 0. Okay, na? Net gravitational field is equal to 0. Suppose here small mass, you can consider gravitational field in this direction. Here small mass, gravitational field in this direction. Here small mass, gravitational field in this direction. So like that, the small masses you can consider and gravitational field act in the direction. The gravitational field at center is equal to 0. So mass is distributed symmetrically. The gravitational field is 0 at center. An example. So null point, you can find out the null point. Suppose this is the mass of a particle is m and this is 4m. Distance between the two masses is 9 centimeters. So this is distance between two masses, 9 centimeters. At a point O, the null point means what? Net, where net gravitational field becomes 0. That point is called what? Null point. So you can find out from M1 to null point how much distance is there. You can find out that, right? So due to this mass, gravitational field act in this direction, that is E1. Due to this mass, gravitational field act in this direction, that is what? E2. So here E1 is equal to E2. So this distance is what? This is 9 centimeters, means this is 9 minus x centimeters. So due to E1, so due to this mass, what is gravitational field? E1 is equal to capital G m by x square. So due to this gravitational field, E2 is equal to capital G 4m by 9 minus x whole square. Right? So due to where net gravitational field becomes 0, these two becomes equal. So E1 is equal to E2. Both equate, you can equate. So capital G m by x square is equal to capital G 4 m by 9 minus x whole square. So you can find out where net gravitational field becomes 0, means null point you can find out from M1 mass. So this capital G cancel, this m cancel. So 9 minus x by x, 9 minus x whole square by x square is equal to 4. So can I write 9 minus x by x is equal to 2, plus or minus 2. You can write plus or minus 2. So 9 minus x is equal to 2x. This x bring this side. So 9 is equal to 3x. 3 1s, 3 3s. So x is equal to 3 centimeters. From this mass m to 3 centimeters, the net gravitational field is equal to 0. Net gravitational field is equal to 0. So this is null point. From m1 to how much distance null point is there? 3 centimeters. 3 centimeters. Next, a semicircular ring of a mass. Semicircular ring of a mass is m and radius is r. You can find a gravitational field at center. At a center. You can find a gravitational field at a center O. At a center O. Consider a semicircular of a ring of mass is m and radius is r. You can find out gravitational field at center O. Gravitational field at a center O. Right? Suppose I will consider a small element of a mass m, that is dm. So that dm makes an angle theta with this reference. So what about this dm makes an angle d theta. So here due to dm, this mass, so gravitational field act in this direction, that is what dE. That is dE. Similarly, here a small element, here small element, small element, small element, small element, small element, small element, you can do like that. Okay, na? And net gravitational field you can find out. Suppose due to this E, so in this direction, one gravitational field is acting, that this dE resolved into two components. Along the horizontal is what dE cos theta, and along the vertical that is dE sin theta. dE sin theta. I will consider one more here dm, this side, small dm, and due to this dm, so angle is what? Angle suspended at this is d theta, and this angle is what? Theta. So here dE is acting in this direction. So the dE resolved into two components. Along the horizontal is what? dE cos theta, and along the vertical is what? dE sin theta. dE sin theta. Here mass you can consider this along the horizontal is dE cos theta, and along the vertical is dE sin theta. So this dE cos theta cancel. Only dE sin theta is add up. dE sin theta is add up. So what if net gravitational field is equal to integration? You can do integration dE sin theta from 0 to 180, from 0 to pi. You can find out this. So first you can find out small dE. Here I am doing. Okay. For dm, angle suspended is theta. So see this one. This part is dm. This radius is r. This angle is d theta. So what is here? For total mass is capital M, and here theta is equal to the total angle is theta. So semicircular no total area is pi r. Suppose consider total mass is m, and here what is semicircular area is pi r. Here similarly same dm by r d theta. This is capital R d theta. So r d theta. From this you can find out dm value. So dm is equal to this r cancel, capital M by pi d theta. So in place of dm you can write a capital M by pi d theta right here. So E is equal to integration 0 to pi capital M by So E is equal to integration 0 to pi, integration 0 to pi. So what about dE? dE is equal to capital G dm by r square. R square means what here? R square. Capital G dm by, what about distance here? R, radius, r square sin theta. Sin theta. So here capital G r square is common, capital G r square is common, r square, integration 0 to pi. You can write here dm, substitute here dm. So I will consider this is a small arc. So this is dm, this is d theta, this is radius is r. So here total mass is, this ring total mass is capital M, and what about this area? Pi r is equal to this small dm, and what about this r d theta? You can find out here area r d theta, right? So this r cancel. I want dm is equal to capital M by pi d theta. So here place of dm you can write capital M by pi d theta, capital M by pi d theta pi sin theta d theta, sin theta d theta. M by pi also common, constant. So here E is equal to capital G capital M by r square into pi integration 0 to pi sin theta d theta, sin theta d theta. So E is equal to capital G capital M by pi r square. So integration of sin theta is minus cos theta from limits 0 to pi. So E is equal to capital G capital M by pi r square. So substitute the limits. First you can substitute pi. So cos pi is equal to, right here, minus capital G capital M by r square. Cos theta cos 180 is equal to cos pi minus cos 0. So E is equal to minus capital G capital M by pi r square into cos pi value, cos 180 is minus 1, minus cos 0 is minus 1. So E is equal to minus capital G capital M by pi r square into minus 2, this minus plus, E is equal to capital G capital M 2 capital G capital M by pi r square. So this is the net gravitational field of a ring of a mass m and radius is r. And see, this is along the y-axis. So you can consider this is j cap. So in case they will ask what is the net gravitational field of a semicircular ring, in case they will ask gravitational force, what is the gravitational force? So based on gravitational field formula, E is equal to F by m. So from this F is equal to, you can write me. So already E you know. So 2 capital G capital M small m by pi r square. So this is F along the j cap. So this is the gravitational force, this is the gravitational field of a semicircular of a ring of a mass is m, radius is r. You can find out the gravitational field at center O. E is equal to 2 capital G capital M by pi r square, okay na, along the j cap. And the force is equal to 2 capital G capital M small m by pi r square into j cap. Quadrant of a ring of a mass m and radius is r, find the gravitational field. So quadrant of a ring you can consider. This is quadrant of a ring of a mass is m and radius is r. This radius is r and this mass is m. You can find out. So similarly, before we did know what semicircular of a ring. Similarly, like that only you can do. Suppose I will consider a small element of a mass dm here. So this angle suspended at center is d theta. So here gravitational field act in this direction, that is dE. So this makes an angle theta with the horizontal. So this dE resolve into two components, along the horizontal and along the vertical. Along the horizontal is dE cos theta and along the vertical is dE sin theta. Means here dE sin theta along the x-axis, dE sin theta along the y-axis. You can find out these two. Okay. So dE along the x-axis, you can find out along the x-axis, and E along the y-axis. You can find out. E along the x-axis is equal to integration dE cos theta. So along the vertical, integration dE sin theta. What is here dm? Dm is equal to, here Ex is equal to integration dE is equal to capital G capital dm by r square cos theta. So here also Ey is equal to integration capital G dm by r square into sin theta. From where to where you can find out? From 0 to pi. You can find out. So limits from 0 to pi. Angle is how much? 90 degrees. From 0 to find out gravitational field, you can find out 0 to 90. 0 to pi by 2. 0 to pi by 2. Here 0 to pi by 2. So what is the here dm? Dm value you can find out. Here this capital M by this area is equal to pi r by 2. And what about this one, small dm? Dm by r d theta. So this r cancel. So 2 capital M d theta by pi is equal to dm. So in place of dm substitute. So Ex is equal to integration 0 to pi by 2, and capital G is common and r square is common. Capital G by r square is common. So here 2 capital M by pi cos theta d theta. Here also same only. Ey is equal to, here common is capital G by r square, integration 0 to pi by 2. So substitute the dm value, 2 capital M by pi sin theta d theta. So here 2 capital M by pi also constant common, that is Ex is equal to 2 capital G capital M by pi r square. Integration cos theta is minus sin theta from 0 to pi by 2. So here also same. So 2 capital G capital M by pi r square. Integration sin theta is cos theta from 0 to pi by 2. Integration cos theta is minus sin theta only, and integration sin theta is equal to minus cos theta. So substitute the limits now. So integration cos theta is sin theta, and integration sin theta is cos theta is equal to sin theta, and sin theta is equal to minus cos theta. Substitute the limits. So Ex is equal to 2 capital G capital M by pi r square. So sin theta sin pi by 2 minus sin 0. Sin 0 is 0, sin pi by 2 is 1. So can I write Ex is equal to 2 capital G capital M by pi r square into 1. So similarly here minus is common. So Ey is equal to minus 2 capital G capital M by pi r square. So cos pi by 2 is 0, 0 minus cos 0 is 1. Cos 0 is 1. So minus into minus plus. So here Ey is equal to 2 capital G capital M by pi r square. So what is, you can find out the net field. So net field is equal to E net is equal to Ex plus Ey. Ex plus Ey. So 2G capital M pi r square, 2G capital M by pi r square, can add both. C net is equal to Ex bar Ey bar. So this is along the x-axis is E and along the y-axis only E only, both are same magnitude you will get. So net gravitational field is acting in this direction. So here E net is equal to, both are same magnitude and this is 90 degrees, means you can write root 2E. So can I write this one? Both are equal magnitudes. So you can write what is the magnitude of net gravitational field is equal to root 2E. What about E? So root 2 into E is equal to 2 capital G capital M by pi r square. So you can write E is equal to 2 root 2 capital G capital M by pi r square. So this is the answer. So this is the arc of a mass m and radius is r. Find the gravitational field at P. So this is makes an angle, I will consider pi. So you can draw the one reference line. So I will consider here small element dm here, small element dm. So this is dm. Angle suspended at dm. Here angle is what? d theta, and this angle is theta I will consider. So here gravitational field acts in this direction, that is small d. The d resolved into two components, along the horizontal, along the vertical and along the horizontal. Along the theta is de cos theta, other than theta is de sin theta. Similarly, I will consider this side also small element dm. So this is angle suspended at angle is same similarly. So this side de sin theta and this is acting upward. This is de cos theta is add up. So de cos theta. So this angle, this gravitational field is cancelled. So along the vertical again gravitational field is add up. Okay. So what is net gravitational field? E is equal to integration de cos theta. From angle where to where? So this is total pi, mean this side angle is pi by 2 and this side angle is, total angle is pi by 2. So this is minus pi by 2, this is plus pi by 2. So you can integrate from minus pi by 2 to plus pi by 2. So what about dE here? So E is equal to integration minus pi by 2 to plus pi by 2. So dE is equal to capital G dm by radius is equal to r square cos theta. So you can find out dm here. What is dm? So here total mass is m. And what is the angle is pi and radius is r. So pi r is equal to small dm by r d theta. So here this r cancel. So dm is equal to capital M by pi d theta, capital M by pi d theta. So substitute in place of dm, so E is equal to, here capital G by r square is common, capital G by r square is common, integration pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2. So capital M by pi sin theta, here theta is cos theta d theta, here M by pi also constant, you can common. So capital G by capital M by pi r square, angle is pi, okay na. So integration cos theta is equal to what? Sin theta, from limits pi by minus pi by 2 to plus pi by 2. So substitute the values, the limits. So E is equal to capital G capital M by pi r square sin pi by 2 minus sin pi by 2. So here minus pi by 2 means this is minus pi by 2, minus into minus plus. So E is equal to capital G capital M by pi r square, 2 times of minus into minus plus 2 times of sin pi by 2, 2 times of sin pi by 2. So final answer is E is equal to 2 capital G capital M by pi r square sin pi by 2. So this is the gravitational field at point P. So today's session is completed. So watch my videos, subscribe my videos and like my videos. I love you, bye, take care, have a nice day. Okay na, today's session is completed. We can meet tomorrow.